Okay, hello guys. I want to take you through the process of like converting your Unreal scenes on objects and era props, or the entire scene if that's what you're going for. And I just want to present a way of turning or converting that into dataset that's already for Gaussian trainers, just prepping the data out of Unreal that is already aligned and is ready to just throw into your trainers and convert your scenes into Gaussian splats for all sorts of use cases, from your web configurators, Gaussian splats have just become so popular, in the ArcViz industry, in the automotive industry, and you can see like DCCs like Houdini are really developing tools for Gaussian splats. So I thought I'd make a tool here, just a simple a tool that allows you to do your captures and alignments inside of Unreal, so you can capture your scenes, light them and prep them and convert them into Gaussian splats, high fidelity Gaussian splats for all use cases. So here I have a simple scene. It's a studio setup that I've built, a simple studio with simple lighting that you can tweak. I'll be providing all these, so you can just play around with these scenes. So let's get started. So the tool here, it's a plugin built in C++, so it integrates well with the engine, as all these categories. Let me just collapse them. I just want to show you like how to export, and then we'll go through the review of all the settings in the tool. So here, if I have the methods that I'm using to capture. We have different methods. For hero props and small, almost circular objects, we use the Fibonacci DOM. I'm using the Fibonacci DOM. So if I draw the camera part here, you see there's an estimate of the number of frames I need to export for this simple scene. I just want to show you like the showcase first, and then we'll go through the settings and everything else in the tool. So this is an estimated number of frames. So 600 images will be stitched up to make the splat. So I'm just gonna lower that to, you see here, these are frames per shell. I'm just gonna go with like 500 for now, because that's this is a simple, relatively simple object, so this should be enough. And I'm only using one shell. When you go through these, I'll take you through all the settings. So I'm just gonna export the simple scene just to show you what the tool exports and the kind of data set it preps for you. So just gonna press. So you can also snap to the camera and just scrub to see what each camera will be looking at, just to make sure you have enough overlap and stuff for your data set. Yeah, so that's a quality of life feature. I'm just gonna turn those off and execute the sequence. It just executes using MRQ. I'll be back when it's done. As you notice here, the object is deep edged. It's cut out from the rest of the background. So I have a feature that just allows you to separate the objects you wanna export or render out, or you can just render out the whole scene if you bypass the mask option. So it's done here. Generating the synthetic point cloud. So it's done. So the next option is organize and train. So I've piped a Lichfield executable, so mine will just open Lichfield automatically, but that's an option you can turn on and off. If you don't need to, you can use other trainers, but for this one I'm using Lichfield. So if I do organize and training, it will downscale my images because I captured at 4K and I need to squash them down to like 1920 by 1080 because of VRAM. I only have like a laptop GPU, so yeah, just to avoid crashes and stuff, I'm just downscaling my images, to HD. Yeah, so it's turning off to Lichfield, tells you to close Unreal to save VRAM. I'm just gonna switch over to Lichfield just to show you. So the data set as it comes in, I'm gonna maybe use 1 million splats. I'm just gonna reset the training. Just use 1 million for now. No alpha. because it's already, I mean, it's already a PNG with an alpha channel. So if you turn off the cameras, you can see the point cloud just before it starts training. If you start training, yeah. So you see that what the tool does is output like a COMAP dataset that is required for these trainers. I'll take you through the structure of what it exports. So this is what the tool exports. It exports in a specific folder directory that you choose, and then it essentially just makes the COMAP folder for you. Inside the COMAP folder, these are just pipeline trackers to track appending to if you want to append to your data set. So these are just used by the tool just to track the progress and to track the data and stuff. But for the COMAP dataset, all you need is just the images and the sparse folder. This is where we write out the final splat. So just these two folders, and inside the images folder, these has all your images, the 500 of them. You can just go through them and see. Yeah, you see those are your images. And then in the sparse folder, as like a subfolder, and inside the subfolder we have the text files, we have the camera. So this just writes out the type of camera used for the data set. So it's a pinhole of type pinhole, and the resolutions, yeah, and these are the parameters there. And then the images, it attaches each image to the camera because this is the camera ID. So we only have one focal length, so it's one camera ID, and then the image ID, and then these are the variables or the parameters for COMAP needed by the trainers. So it creates all this for you, the images, and then we have a point cloud. This contains the point cloud data that is generated at the end of the execution. When the render is done, it executes like a one pass for the point cloud, generates this one for you, and you can just drag this folder, the entire folder, into your list field. So I have mine, which just out opens, and you can already see the quality of the splat at 6% with only less than 1 million splats. So you get really clean splats. The data set just is very clean, so you don't have to gaze inside your trainers and stuff. So it's really clean data for any kinds of objects that you need, you know. And if you have proper methods, proper capture methods, you'll get really good data sets, and then with the resolutions and stuff. So if I close Lichfield, I'll show you how you can just drag the folder in. So if I use my Lichfield here, I open the application. You see you can import PLY, SOG, SPV, USD, COMAP dataset. So I'm just gonna drop these COMAP dataset, the old folder. You see the images on the sparse folder get recognized, and then you can just load. Tells you the images and it's ready. You can choose. I'm using Mr. Nav for now. Just gonna have one and start training. I can turn off the camera. You see the camera matches the dome that we had in the tool and drill. So it's quite intuitive. Yeah, so that's about it for the preview. Now let's move on to installing the plugin. So here is an empty studio that I'll be providing for you to play with. I have this tool. I have this tool built in Houdini just as a showcase. You can place your props here and stuff. So installing is pretty straightforward. You just drop the plugin in your plugin folder as you would for any other Unreal plugin. So if you go to individual projects in the plugins folder, if you don't have a plugin folder, you simply create a folder called plugins in your projects directory, and on the plugins you just unzip and you drop the tool here. It'll just be a zipped file. You just drop it here in the plugins, and then when you start your project, you go to plugins. On the projects, you'll find it here. So it has like a little description. I'll be providing full documentation for the tool. So with an in-depth documentation, you'll be able to go through everything. I mean, all the settings and all the features in the plugin. So once you have that installed, there's an option to launch it here in the tools panel. So if you come here in the tools, it has a category here called Gaussian splatting. So just spawn the rig, simply just, yeah, with that, and the guy is spawned. You can see it's called Gaussian splat, Gaussian capture rig. I'm just gonna collapse all the categories, move it. I'm just gonna move it, yeah. You see there's like a radio, like a sphere visualizer. This is for some of those methods here. So the Fibonacci is default. So that's, we have 1, 2 shells. I'm gonna get rid of that. Just so as a showcase, I'll just drop a simple model here. I'm gonna use Houdini's capybara. So I'll not be providing these because of, you know, IP issues. This is Houdini's IP, but I mean all the other assets from that are free from like Polyhaven, I'll be providing them and linking them in the description. So we can just drag the textured capybara. Yeah. I'm just gonna scale him up. I just want him to sit on the stool. There doesn't have to be big, you know, doesn't have to be exact. And I can just, yeah. So we have capybara there. And just to center the tool, I'm just gonna copy the position of capybara and add that on the tool, paste there. So we have different capture methods. I'm just gonna go through everything, then we'll go through each category one by one. The pipeline controls, these are like quality of life for live previews on the viewport. You can see we have a live scrubber category and a render engine category that allows you to have your own configs or use Splat tracer if you want to. And then you see this one is a camera path, estimated frames, just shows you the number of frames you need to be exporting. You can preview where the camera is looking at by snapping and visualize the point cloud, because essentially you need point cloud data for the Colmap dataset workflow. So yeah, there's a general capture. This is where you'll find all the methods. These are extra debug options for to show cameras and the debugs icon size. So in the general capture methods, we have the Fibonacci dome, which is good for props. We have the cylinder for large subjects. We have the spherical orbit, you know, the drone orbits, they just a spherical spiral. We have meridian arcs, which run on the longitudinal of the curve. And then we have the photogrammetry cage and a slam walkthrough, which is the most robust method I have here with all automation using splines, multi-tier strategies and stuff like that. I'll take you through that. And when you select each of these modes, you see here the subcategory just switches, so it's not so cluttered. So if you're dealing with the cylinder, you only have controls for the cylinder method. If it's on the Fibonacci, you have controls only tied to the Fibonacci method. If it's the spherical, I mean, it's the same. You have controls only for that methods. And then down here, still on the pipeline controls, on the general control, sorry, we have targets and filters. So this is, I mean, for your targets, because essentially you want to have target objects that maybe your camera will be focusing on. And then I've built the tool around the idea of multiple targets. So instead of just having one target, you can have multiple targets, and the cameras just look at the neighbor, using a neighbor search. They just find the closest camera and they align the targets to that, and there's a small blending, so you have a smooth blend between focal points or focal targets. And so that's for the targets and filters. And then we have slam and automation. These are of controls for these slam methods. And then lens and render, these will control, the export settings and the camera optics. And then export and pipelines, these controls, the pipeline controls like your file directory, your masking and stuff like that. We'll go through all those in depth. And then there's a point cloud generation that deals with generating point clouds that you need for the data set. And there's a quality of life feature called NBV, the next best view, just tries to use the next best view algorithms to place cameras where it might have been stabbed, where these methods might have missed. So yeah, it's a quality of life feature that you can use. Yeah, that's just the most general overview. Now we'll go through each one of these methods individually, separately. Let's move on to the capture methods. Before we go to the capture methods here in the pipeline controls, you see we have these buttons here. These is just for final execution of the sequence. The quick setup here allows you to quickly attach a pivot points. It spawns a pivot point like a target points and a bound, because there's a bound here for Pointcloud generation. You need like a bound. So the point cloud will only be generated within these bounds and not outside. So anything outside the box will get killed. So this is just a quality of life, like a quick setup. If you press the quick setup here, materials get linked. So we have materials for the masking, which get attached in the tool. I have them here as contents for the plugin. We have all these contents that come with the tool. The planner, this is for the visual planner. I'll take you through that. The stencil, this material just handles the masking. If you go inside the material, it's a quick post-process material that takes on, that essentially just cuts out the alpha for the selected or tagged objects. And then we have like this is like a 2D capture component for the slammer method. I'll show you when we get there. And then it's just like render targets for the shader. And the quick setup just sets these things up for you. The point cloud bounds, you see it's already made and set. You can see the bound here, point cloud bounds. We can scale it up. Let's see, maybe 60 or something. 60. And then we have like a target focal length. It just makes one and attaches it here to the caption targets. You see it's an array, but right now it only attaches one for you. Yeah, that's just a quick setup button. So let's go through the first method, the Fibonacci DOM. You see in the Fibonacci DOM, if you have that selected, you have the Fibonacci options. So for the Fibonacci DOM, this just allows for like a distribution of points around a sphere. That's how they work. So if you come here, we don't have any parts generated. Generate light parts. You see we have 150 points. If you throw the debug, throw the camera part, this shows you where the camera nodes are, and you see the icons are really big. So here is an option for controlling the visualizers here, the icon, and you can see that with the target, they're all following the target. If you move the target, you see all the camera nodes point towards the target. And this is just using, if I'm using one target, let's say you want an extra target here. I'm just going to duplicate this guy, put it there, go to the rig. And I had another element to the targets and filters. I had an extra focal element. I'm just going to use the second focal length. And you can see what's happening. It's blending between the two focal points. You can either have smooth blending or just like linear blending. And then if you snap to the camera and try and preview, it just runs through each of the camera nodes and shows you what the camera is looking at before you export the sequence. So for the Fibonacci method, we have option for distant shells. So let's say you want to have like multiple shells around your objects. I don't know what use cases you might have for that, but just in case you need to have multiple just to capture more of the objects, you can add an extra index to the DOM and then maybe make it larger, and then you see like all the with the visualizers, it gives you an idea of the sizes and the distance of the actual cameras to the object. You see if you change it, it updates, and now you can generate your flight path, and you see just snap to the camera, it goes around all the 2 shells, and then you have the total number of frames estimated here, and then there's an option to randomize the DOM rotations. If you see if you get that on and off, and then there's a rotation jitter, so the jitter amount you want, you can jitter the rotation, and then you can add a jitter to the positions too, so you don't have like perfect distribution of the camera nodes around the sphere using the Fibonacci. Using the Fibonacci uses golden ratio essentially just to distribute the points around the sphere. So if you don't want any jitters, you can turn that off. But I have some jitter, and then I have a seed for the jitter, so you have different seeds. Maybe you want multiple runs, and you want like for each run to have a different seed. There's an option there, and then there's the Fibonacci as like a sweep angle, so you can have like a 360 DOM, see, or a 180. Like this is like a full 360 DOM, just shows the sweep angle. And then the Fibonacci bottom-up options allows you to invert the direction of the DOM, so it starts from the bottom instead of the up. So if we have that, you see the DOM starts all the way down. Yeah, it starts from the bottom and start sweeping upwards. If you scrub your cameras here, you can see what's happening, but it's mostly looking at the ground, so that's why you're seeing in the preview here, because the preview windows allows you to see what your cameras will export. Yeah, and then that's all for the Fibonacci methods. You see, you can add as many shells as you want, just to see what works for you. Yeah. The next method, the Fibonacci, is a cylinder for large subjects. Just like the Fibonacci DOM, each one of these methods has a radius that gets visualized. So you see, shows you the radius of the capture, or the region you capture, and then you can generate the flight paths and see, draw, and then you see what's happening with the cylinder methods. If you go through the cylinder controls, we have the number of Z steps. This controls the number of cylinder sweeps. So let's say you only want one of them, you can move the whole thing down, and you see it still has the focus, still uses the focus here, the targets that we set up here, and then this controls the number of frames, the number of cameras around each ring of the cylinder. Say we have 3 of these guys, and then we have like a spacing option, so this allows you to space them accordingly. So, and you can see, it's just up the debug to like a 0.2. You can see the orientation, where the camera is looking at using these debugs or visualizers here. And if you snap to the camera, just go around, it shows you exactly what you'll capture, how your data set will look like. You can always change these things, and they update live. See the spacing and the number of rings that you want on the methods. So you see the kind of capture you get if you scrub through. You see every update, the number of frames here, the estimate gets updated automatically, so you have a good idea of the number of frames you need to export in the data set. Yeah, and just scrub through them, just like with the view. So that's the cylinder method, and the next method is a spherical spiral, or drone orbit. You can see that the camera path just like orbits around the subject, and if you go through the controls of the spherical spiral, yeah, you see the same option with using the radius. You can still use the radius, and then total spiral frames is total number of frames around the spiral. We can have 10, we can have 1,000 frames. I mean 100 frames, 250 frames, depends on what you want. And if you scrub through, you see what's happening, and it still follows the targets, you see. And then you can keep the camera level. You see now, as you go up, because of the targets, all these targets, I mean all the nodes just point to the target, but then you can flatten the pitch. If you do that, you see now they're all looking straight on, like the pitch is flattened along the curves. So if you scrub along, you see what's happening there. I'm just gonna turn that off. There's an option to invert the direction of the spiral, you know, just so it starts different, like clockwise and anti-clockwise direction. And then you have the number of revolutions per spiral, maybe let's say 2, 10, whatever number you want. Just controls the number. And all these, if you just over all these variables have tooltips, so it's, I mean, I have tooltips for all of them, so it just explains what each one of those does. So it's quite intuitive. And then there's an option to use the variable radius. So you just use the variable spiral radius here. This allows you to define your, I mean, you see the inner and the outer radius, and then the starting of the elevation just allows you to have full control of the spiral part with elevation controls and stuff. We have minimum elevation, maximum elevations, and yeah, everything just works. You can just tweak this thing to your needs, depending on the data set you want to capture, on the scene, on the size of the subject, on the complexity of the scene. If you have like multiple scene, like a whole, maybe an outdoor scene, maybe you want to capture maybe buildings, or just objects which are kit bashed or mashed together, you know, just for all kind of scenario cases, you know, just see what works best. But this is mostly for things like trees, you know, that you need to orbit around, and it's such a big shape with very organic shapes. So this method works for such cases. Yeah. The next method we're gonna look at, I'm just gonna turn these guys on. It's the meridian hacks of the WISP. It's the same way you see the visualizers here and the radius scales for each individual method. Let's just do like a throw camera path to see what is happening with the meridian arc. So you see they just like run longitudinal along the curve. You see this snap here. This is a good point to see what's happening with the blending when you have multiple targets. You see these ash blend here. If I go to the targets and filters and have like smooth blending, you see how that fixes it. And then you can have the more this value, the blend of, it just tries to blend to the actual midpoints of the targets, you know. So it's like an exponential multiplier, this one, just to try and make sure the blending is not like super smooth. And then there's an option to also keep the camera levels here when you don't have any targets, but this only works when you don't have any targets attached here. Yeah, the smooth blending. So for the meridian arcs, we have the radius and the number of parts and the number of frames along the meridian arc. Maybe let's say we have 3 arcs, and we can come here and snap our camera, and you see how the camera travels along the meridian arcs as they're arcing through the subjects. So this is used for things like maybe if you want to capture your cranes and stuff like that. So the next method we're going through here is the photogrammetry cage. So this method just tries to mimic like a photogrammetry kind of studio setup where they capture like subjects for, I mean, is it 3D scanning and stuff like that. So I'm just gonna generate flight path. Just gonna throw the path. So yeah. So for the method, just as like a radius, you know, just radius of the cage, and then it has the number of poles around the cage. So you can have 10 poles, 1 pole, 2 poles, I mean 10 and 5, the number of poles that you want. And then this is camera, yeah, the number of cameras in each one of these poles. You can have like 2, 12 or something, I mean 12. And then if you snap the camera and go through them, just you to get an idea of what each node is looking at. Yeah, just scrub through. I'm just gonna keep the flight path visualizer on. And then we have these controls, just controls the length and the sizes of these gauges, like the minimum, the lowest camera height, and the maximum camera height, to see what's happening there. And then there's an option for jitter, to jitter the cage too, and a jitter seed. But when it's 0, we don't have any jitter seed, so I'm just gonna keep that at 0 for now. And then here we have an option for cage to ignore because we have like focus settings here in the targets and filters. You can choose to ignore those. Right now it's ignoring those. It's using its own it's just using pitch. You see here, if we have this option already ignored, and we have camera cage convergence, you see the 0 camera looks straight ahead, flat pitch 1, converge to the vertical center. That's the center of the rig, so they try to converge at the center. If we convergence at like 1, you see what's happening here. These bottom nodes, they really try to converge to the center, and you can increase you see this amount. It explains it's 1 is when it's linear, 3 keeps the middle of the pole perfectly flat and sharply bends the pitch only at the extreme tops and bottoms. You see here what happens. It's only the bottom parts that get really bent. But then if you have this option turned off, it uses the global targets that you have set here. So I mean, those are all the controls for the photogrammetry method. As its use case is just like all the other methods. Yeah, you see now we only have 60 frames because we have 5 cameras and 12 poles. We do the maths, that's 60. Yeah, so that is about that for that method. So the last method we're going to look at here in the capture methods is the SLAM walkthrough. This is the most robust method that allows for spline controls and localized controls, manual cameras, and local regions of interest. So let's go through the method. You see, if you switch to the methods here, automatically it displays there's a spline that gets spawned. I mean, the spline is already attached to the rig, just gets shown up when you switch the method. So this is the default spline, but you can add other splines if you want. I mean, this just comes attached to the rig just to show you how it works. I'm just gonna move it here. I'm just gonna draw a simple spline path first of all to show you how it talks to the method. I'm just simply gonna draw like a I'm just gonna draw something. I'm gonna have a close spline, so it's so for instance, something like that. Just gonna move the whole spline there. Yeah. So let's go through the controls of the method. If you see in the SLAM and automation, we have all these things. First of all, clear spline points. This allows you to clear all this. You see now I've already like made all the imagining of all this, all your spline points already drawn. If you clear, I mean, you clear all the points. I mean, just clears what you have and starts with just 2 points. That's just to make it easy for you to draw the curve. I'm just gonna simply gonna redo it. So that's the clear option, allows you to clear the spline. This option allows you to very quickly generate like a circular spline with these options: the spline radius, the circular path radius, and the number of points. Maybe you want to generate a 25 centimeter radius path, generate circular spline. Pop, it converts the the SLAM walkthrough spline into like a circular spline, just like a quality of life feature. Just for quick splines, if you don't want to draw and you want a circular spline around your object. So this quickly does that. You can see I did move. You can move the rig, but I mean, I don't want to move the rig. I want to move the actual spline. I'm just gonna move it here. yeah, I mean, I think 25 is a lot, so I'm just gonna clear the splines. Have my own simple spline setup. And I'm just gonna add that. Yeah. If you come back to the rig, there's a launch. I'll take you through these methods in the interior showcase. This is very useful for like interiors and outdoor spaces, just as a 2D planner to help you draw your cars and stuff. And then the map planner, these things, when you launch the plans, the slum planner, all these things will get populated for you, like the BP, it's like a 2D capture component will get attached here. Let's go through the basic things first of all, like the padding and how this method works first of all. So here we have spline distributions. So first of all, go to the padding. I'm gonna make sure I don't have multi-test strategy and just generate a flight path, show you, I mean, first of all, the points along the sphere. You see it generates 91 nodes around this curve. You can see the orientation is all messed up at first. And then here we have a distribution methods for the points along the spline. So you can distribute distance based. So this allows you to like 50, and then this is curling around corners. If you have sharp corners and you want to capture those, there's just options for that. So we have a distance based every X centimeters, maybe every 100 centimeters. You have nodes. You have number of five frames. Let's say we go with something like 20. How many frames do you have? 24. Yeah, self-explanatory. And then there's a fixed number of frames. So this is just an explicit fixed number, maybe 120. Usually you only have 120 frames. It's 116 because of the culling, because fixing this is option to fix colliding cameras. That's why you see now we have 120. We don't have any cameras fixed because there's an option. If a camera collides with an object, you don't want that in your data set, so you can filter those out and other methods for filtering, but I'll take it through. And the other method is adaptive dense spaced curves. So this is for instance where you want to have more points in regions of high curvature along the curve. So you use things like these with a threshold of 2, maybe 5 and stuff. So you have more point distribution where the curve really bends. Let me see, for instance, here. I'm just trying to make this point sharp, so you see point distribution there. Yeah, you know. Yeah, there's certainly more points where the curve is really sharp, where the curvature is really high. You have more points distribution, adaptive minimum distance, maybe at like 2 to 1. Yeah, that doesn't seem to change much. Yeah, I mean, this is just controlling distribution. You can choose, but I mean, even these other methods work, but I mean, just to give you extra controls. Right now, as you see, the orientation of the curves, I mean, it's like pointing tangentially along the tangents of the curve. And if you look at the preview, if you snap to the camera, you see how the camera will move. So this is not very usable. So there's an option here for, there's a slam looker target. So when you have this option on, all the slam cameras will look at these targets here, because they're off by default, but they can look at the target. If you want all your cameras along the spline to point at the target, they can point at the targets there. And then let's go back. You can turn off the targeting. We're in the padding subcategory. These are this is the option to filter cameras that collide, and there's a distance for collision. You just change your collision radius here for the distance you want the camera to calculate before it gets removed from the nodes in the final path calculation. And then there's an option here to use multi-tier. So multi-tier allows you to have like multi-tier curves, just copying the curve along the z-axis, just the y, just upwards, just duplicates the curves, copies them. So if we have the spacing here, you see all the curves that go down, they don't get deleted, just go up all the way down there. But there are options to delete all the cameras that go with exclusion methods and stuff. I'll show you that. I don't want to move the old rig, I just want to control the spacings. But yeah, for this instance, you can move the rig just to get your splines how you want them. I'm just gonna space them a bit like these, and you can increase the number of tiers that you want. Right now we only have 3. You can turn that into 5 and 1, whatever you want. There's an option to skip the middle tier. You see, it just skips the middle one from the camera path calculation, so it doesn't get included in the final camera nodes. It's a quality of life feature there. And then we have these pitches. See, there's a base pitch, and then we have like for each one of the curves. If you want to, because essentially when you're capturing objects like these, you want these nodes that are down here to have like an upward pitch, and guys that are happier to have like a downward pitch, so just like pointing downs to capture, to make sure you capture the whole object. I'm just gonna turn those guys. I'm just gonna turn them off, have them at 0, 0. And then here, there's an option to use sideways scanning. So let me turn that on so I'll show you what that looks like. So you see now it doesn't use the target or the focus points. The orientation changes. It's always like pointing inwards or outwards of the curve with pitch controls. So you see the camera nodes using these visualizers, they're pointing outwards. There's an option to reverse, sideways invert. See, when they're inverted, they now look inwards, all of them. And if you do your snap to camera and move around, you see now as the camera nodes move around the object, they are always pointing inwards. You see now they capture the object because they're always pointing inwards to the direction of the hero object. And then in these SLAM methods, there's a pitch offset. You see, you can have like a global pitch offset for all these curves, like 15 or something. Let's turn that as 0, and then there's a SLAM pitch offset per tier. Let's make that 15 on negative 15. So you see now how it affects the pitch. So the nodes that are on the lower tier are looking almost upwards, pitched upwards, and the nodes that are on the topmost tier they're pointing downwards. The elevation is pointing downwards. If we do some bit of spacing here just to see how that looks, and you scrub through the cameras that got skipped. So yeah, so that's the basics for the multi-tier strategy using the curves. Still on the SLAM walkthrough method, there's an option to also attach your own splines. You don't need to use the attach spline. You can add extra splines if you want more control. I'm just gonna add a spline to the component here. You see it automatically gets attached to the camera path calculation. I'm just gonna turn that off. Just move this guy up a bit so you get an idea. I'm just gonna move him all the way up here. So you see, even with extra curves, it adds to your camera nodes calculations. So I'm just gonna generate flight path. So you see with the new paths here, we also have the nodes generated and they get added up. And if we tweak this guy, where is he? Yeah, we need to update this guy just a bit. Yeah, you see. And if you rotate it, the orientation changes, because if you take this guy and do your rotations, and I'm just gonna maybe just a bit to update. You see, yeah, it updates. So that's extra parts. I'm just gonna delete that. Okay, so the next method we're going to look at, which lives inside the SLAM method, but it's its own method actually. It's called the local regions of interest. If you hover, it just explains to you array of volumes, the level where the rig will generate alter dense orbital clusters to capture eye details. So let's let me put one array. It expects you to have like a target box. I'm gonna create like a trigger volume box here. I'm just gonna place it there. It's too big. I need to scale it up a bit, maybe. This is what's happening. I'm just gonna bring it here. Yeah. So you have this trigger volume. If you go here to the target volume, I'm gonna add the trigger volume as my target. And then in this option, go to the pathing. There's an option to bypass the splines. I'm just gonna add that on, so I don't generate any camera nodes using the spline. And then when I draw my visualizers here, you can see the trigger volume we made here defines the bounds for the curves and for the path generations. If I scale the trigger volume, see it goes on accordingly. If I scale the trigger volume, the paths scale accordingly. Let's see if I scale that guy, make it slightly smaller here. And then I can even do rotations if I want to. And you see it rotates the box. So the idea of these of the local regions of interest is just to have the same setup but using local bounds. Maybe you want to have more details on some certain parts of your scene or certain objects in the scene. You can use like these local regions of interest to define like your parts and your cameras, and they have the same settings as the SLAM method. This is like a target offset, because essentially the target of these boxes is the target of these camera nodes is the center of the trigger box. So if you move the trigger box, they all point to the center of the trigger box. So you can offset the focal point. Instead of pointing at the center of the trigger volume, you know, it just gets offset in the Z direction. And then there's a camera back off, so it just pushes all the camera nodes outwards from the box. Let's say we have like a 10, you see it's just like just pushing it outwards, you know. So you get, maybe if you're getting some sort of clipping or you just want to get more coverage and overlap, you just push these things. And then there's an option for cameras per rings. You can have 20 or whatever the amount of cameras you want. If I come here to snap, just go through and see what's happening, just to see what the cameras are looking at. And you see the number of elevation string. You can have 2, you can have like, yeah, it's a lot, maybe 1 or 2, whatever, you know, maybe 3, depending. And then there's an option for the angle. If you don't want to generate nodes on a whole 360 around the, like on a 360 around the trigger volume, you can control the arc length, you know, just like we did with the spiral orbit method, you see now. And then you can still rotate the trigger box, and it rotates accordingly. So I mean, that's the region you capture. Maybe you just want to capture the back region, that's where you are missing data and need to append that. I mean, this option comes in handy. You can scrub through and just see what you'll be looking at the back there. And then there's an option to add multiple of these things. Maybe because it's an array, essentially, I'm just gonna duplicate this guy. maybe duplicate like the trigger volume, just as an example. I'm just gonna put it down there. And on the second index here, I'll have the second trigger volume. And you see, I'm just gonna move it down. I can change the arc length of this guy. Maybe it's like a full 360 or something. And if I do my snapping and just move around, you see it'll move around. It'll go through all those cameras. You have 120 frames so far. So I mean, it just goes through all of them. Yeah, so that's for the local regions of interest. And on top of that, I have also options for manual cameras, you see. So let's say, for instance, you still want to place some manual cams in some places, like just take full manual control. Maybe here, I can come here, create like a camera at this point, and I want to attach that to my data. So, I mean, it gets included in the path calculation. You see, now I have 121 frames so far. I come here to the manual cams. It's an array. I had one. I had sign camera one. You see the node here. There is like a yellow node gets populated, and the frame count increases by 1 because we have added one camera. And then here there is a debug helper. You can show all the cameras, or you can choose to show only the main path cameras or only for the regions of interest. It doesn't mean they get deleted. It's just like a visualizer and the viewport. And then you can change to only manual patches. These will show you only the cameras that you placed manually. I can duplicate this guy, had another one. Do some rotations, because I mean it respects the rotation of the camera and stuff. And then I come back here in my manual cameras array. I add another one, another guy. You see it gets appended to the data. So I mean it's part of the camera path. You have 122. So when you export, you'll export all the 122 cameras. You can choose to show them in the viewport, just to show all of them, show only main, yeah, show mono patches only. I'm just gonna leave them at show all of them. So those are all the options for the SLAM method, apart from the SLAM planner, which I'll show you in the interior showcase. Yeah, so that's just about it for this one. One other thing I want to show on the SLAM walkthrough method is a 360 cluster option. So if we have, let's go back to the rig. On the SLAM method, on the pathing subcategory here, there's an option called the 360 cluster. There's a guy on YouTube called Fisherman. I mean, I checked his start. He was using like these 360 capture rigs, and then he was doing the processing. He was capturing like with the Insta360 cameras, and then he was doing the stitching in Blender using these three setup of like using 360 camera nodes that then he extracts like frames from each point along the camera node. So that's what I wanted to do. I replicate the same method. So if we turn off the 360 cluster, you see here, and then we go to the spline methods, maybe we have a fixed number of frames like 10 or 5 or even 3. So we have 3 camera nodes, and at each of these camera node, we generate a number of cameras that at each camera node we take like images, maybe let's say 8 images, depending on the amount of images you need to have like a full overlap. At each camera node, you take maybe 8 images that cover the all 360 view. You see, for instance, let me go through. You see now my cluster overlap is at 60%. Maybe I want an overlap of like 20. So if I have 10, you see I have like very few cameras to cover that overlap because they imagine the lens is wide. Maybe let's go with like a 60. So if I snap on a camera and you see what's happening at each camera node, the camera rotates around the yaw, and then it takes like a camera at each rotation. So tap, 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 tap. Takes almost like a 360 view at each camera node. This one has its use cases, you know. I used it in the like interior scenes or like large walkthrough scenes, outdoor scenes where you want to capture each step. take enough images to ensure you have enough overlap. And the method still uses a multi-tier because maybe you want to capture multiple elevation points. Still have options to use the multi-tier strategy on this one. If you turn on the multi-tier, you see what's happening there at each tier, and they still have the pitch controls. You see now these guys are pointing. If I have like 15 or something, yeah, you see it respects the pitch controls, and then goes taking those 360 cameras almost, but now they are decomposed because I mean it's a flat, it's taking like flat images at each one of those camera nodes. You see now we have like 150 frames. If you scrub through them, you see all the cartridges you get for that method. I mean, it has its use cases, that's why I included it. One last thing I want to look at in the SLAM method is the exclusion methods. So these are just culling methods that allows you to get rid of cameras that might be intersecting things, and when they get generated by these splines and they're hard to control, you can get rid of them, just cull them out using exclusion boxes. So if I append one, because it's an array, it expects like a trigger box. I'm just gonna have a trigger box here, trigger box. I'm just gonna have one here. How big is it? The sun's, I think it's quite big. Just gonna drag it here. For instance, there, just to make sure I have some coverage here. Go to the rig and then attach that guy, the trigger box. You see, there's already a guy that got deleted there. Deleted. So if you see what's happening, it deletes everything that is inside the bounds, these bounds here. And you can have multiple of these guys, multiple trigger boxes. Let me have another one there and then attach it to the array here. I have a second trigger box. So you see what's happening. All these guys got deleted where they intersected with the trigger boxes there. So this is very useful if you want to clean up after your generations, after these methods have generated the parts, especially the SLAM method, and you find that you have some intersections. Maybe the camera is looking at some objects which you know will ruin your data set. You just get rid of them with these exclusion methods, and they get excluded from the final camera parts and the final export here, because now we'll only export 91 frames. If we turn these guys off, all of them, we have an export of 153. So yeah, that's just, yeah, for culling. This is an option for culling and deleting nodes that you don't need after you've already generated them. Yeah, so let's quickly go over the targets and filters. So the target and filters in the general capture categories is just for targeting, focus and camera filters, So here there's an option to attach your targets. It's like an array. Instead of having one target, you can have multiple targets that get blended together, either smoothly or just like linearly, just like as a sharp blend. The camera just has like a really sharp blend between the midpoints of each of the target points. So that's when you're not using smooth blending. But when you're using smooth blending, the blending of the targets happens. Let me visualize it here with these methods, with the cylinder methods here. As you can see, the target subjects are already attached. Let's see, instead of keeping the camera level, it's gonna turn it off. I'm just gonna, yeah. So how many targets we have? We have one target, and then we have another target here. So if you come to the target options here, and then we turn off the smooth blending, you see the transition between the two focal points is really sharp. See what happens? It's a very sharp transition. And if we scrub through the generated cameras here, you snap, there's always like such a hard transition because of the focal blending when it's not smoothed out. But once you have the smooth blending option here, the blending is so much better because it smoothly blends between the targets there. Another option is just to keep the camera level, so you see, just flattens the camera on the pitch, just flattens it locks the camera's pitch and roll to 0, so it never tilts up. It's self-explained if you just over the tooltip. And then there's the redundant filter, redundant cameras option. If we have that guy on, you see it through checks the transform JSON and prevents new cameras from spawning on top. So let's say you have done one capture run using this method, and then the next capture runs, we have cameras that are close. So with this option on, it will look at the previous capture using the transform JSON here that gets written out. Where is that guy? I'm just gonna, yeah, using this transform JSON here, it's gonna check. It's gonna open that up pretty quick. Where is that guy? Yeah, it's gonna use the transform JSON, look at the positions here, and if it finds the camera is within a certain range, like really close to this position, it deletes it. So you don't have a data set where you're capturing the same image twice, and that ruins your training. So it takes care of that. And then this is an also option to filter current paths. So this just to make sure that in the current paths, the cameras have a certain distance. So I mean, cameras that are within 10 centimeters of one another get deleted. I mean, it's just a filter option for the current paths that you might find use cases for it. I mean, it's just there. So the next thing category we're going to look at here, I'm just going to collapse these guys. It's the lens and render, the third category here. So this one takes care of all the lens settings and the render settings. So if you go to engine, there's an option to enable panoramic capture. So this allows exporting of equirectangular images 360 if you ever need those for whatever purposes, especially using the 360 cluster. You can just take one camera node at each point and then have the panoramic view, but then you'll have to find a way to, you know, unwrap those ones, you know, just prep them for your trainers and stuff. I mean, it's just an option there. And then there's a render resolution. These just this is an option for setting your resolutions here. I mean, it's self-explanatory, 2160, the 4K, whatever you want. I have it default to 1080. And then a spatial samples. These are the anti-aliasing controls, just like you have in your movie render queue. So you can render with I mean, the number of spatial samples that you need. I'd suggest keeping this guy at 1, because you see, keep at 1. I even have it in the tooltip. Keep at 1 for clean Gaussian datasets to prevent ghosting, because once you have these guys on, you might have ghosting that will really ruin the parallax and stuff and confuse the trainers and stuff. And then there's a disable motion blur option. So these things, motion blur really ruins your datasets for Gaussian trainers. So that's why I have this option turned off. And then local to manual exposure, just to make sure that the exposure is always manual. But if you have your own post processes, I mean, you don't really need these disable tone curve. Just yeah, you can disable the tone curve if you don't want. Just render out. You see, outputs raw linear light, preserves RGB if it's off. And then there's an option to use the level post process. So if you have this turned off, it'll use the post process settings of the attached camera in the rig. So these guys essentially. But I mean, I love it. I mean, I'd leave it on just so you can use your own post process volumes. You can create a post process. You know, I have one here, so that's why I have this option turned on, just to make sure that what I see in the viewport, my lighting matches my final dataset exports. Yeah, these are MRQ capture frame rates. These are frame rates for the sequence. Keep it at 30. It doesn't really matter much for these kind of workflows. And the warm-up frames, 32 is fine. Just render warm-up frames and stuff. And then here we have the camera optics. So this just allows you to define your focal lengths. Maybe you want to capture like a 50, like a 24 something. That's so 40, 24, 12, whatever you wanna capture. So this is static, and there's an option to use the dynamic focal length. So each camera node will choose between the starting and the ending focal length. So whatever you define here, maybe between a 35 and 50. And when you have this option, the data here that we get output, the column of data that we output here in the sparse folder in the cameras here, you see you only have one camera ID because it's only using the static focal length. If we have dynamic focal lengths, these guys will change. So if we have like a 35, we have a camera ID that attaches like a 35 camera with its parameters, and at 50, just depending, and it does the same. It will come and attach because the images need the correct camera ID, so that helps with that, the dynamic focal length. But I found for most cases, Gaussian splatting, just use one lens. So static lens should be fine. That's all about for lenses. Now lens and render. So the next category we're looking at here is the point cloud generation. So this gives you control over your point cloud generations, because essentially you need point clouds for Gaussian splatting data sets, especially the common workflow or data set that this tool generates for you, automatically aligned and stuff, just ready to go into your trainers. So you have a point cloud generation here. This is the point cloud limit bounds that got generated when you press the quick setup here, or you can just attach it. It's essentially just like a bounding volume. If you come here, it's a trigger box. You can add one from the level. So this defines the bounds of the point cloud. Outside these, the bounds of this box, there'll not be any point cloud generated, but point cloud only gets generated like inside the trigger volume, the trigger box. So if you come here, we have few controls for the point cloud: the maximum raycast distance, point cloud per ray per camera, and export debug PLY. So let's try with one method here. If it's not okay, we have the scene exterior here. Draw the camera part, and you see I have the distance already at 1500. If I draw the point cloud, you see the kind of point cloud I'm getting. If I come here, I have the distance as maybe like 10 or something. Is it 10? You see, the distance, you don't get any point clouds, and 1500. And then for the bounds, if you want to see the working, if I move the bounds, or you see the point cloud only gets generated inside these bounds here. Then you can change the number. This one, because this is for the viewport, this one is just a visualizer. I've already capped a number of point clouds you see in the viewport, but essentially when you export, this number defines the number of camera points per ray. If you want a dense point cloud, can have these like at 1,000 or something. This is about for the point cloud, and there's an option here to export a debug PLY. So when this option is on, you see it's if true exports a raw .ply file for filtered synthetic point cloud alongside command. So you can visually verify the geometry before training. So it just outputs like a synthetic a simple synthetic point cloud that you can even drag into DNI, just inspect and see if your point cloud really looks good. You see regions that might be missing. You can do for the point cloud analysis, just to see how to cover things or regions that you might have missed, just for optimization purposes and stuff, just as an option. It's off by default, but you can turn it on. That's just about it for the point cloud. So the next category we're going to look at here is the export and settings, the export and pipeline settings, sorry. So this is all for the controls for the pipeline mostly. Like for output directory, this is where you export your data set. You can just define a path on disk or something. So for instance, here I have mine here. You see this is where the comma of data set and the transform JSON, which tracks the position of the camera nodes. This is where it gets saved. And then we have this option called append to existing capture. So this option, let's say you've captured using the cylinder method. I'm just gonna have it here. But then after you capture the 84 frames, you find that you still need more data set. I mean, that wasn't enough. You still need to cover more areas. Maybe you change your method to something else, to your spherical orbits. This append option allows you to always append to the data set, so it doesn't overwrite. It always appends to the data set. So you append to the methods. The next run you append to the data set. So your data set really grows as you go along. And then the center to column up rig. The center to column up rigs, as it says, it throws centers the column up export coordinate system to the rig's pivot. So you see we have the, like, this is where the rig is at currently. So it will center everything to the rig's pivot here. So this method, if you do one capture run and then you change the pivot, maybe you move the rig up a bit, you'll have a massive mismatch in the data set, and then you'll find you have like duplicate point clouds because the coordinate system shifted. So if you ever need to move, I mean, the actual rig, the rig center after each run, you have to make sure this option is turned off. You don't use that, and you only use Unreal's absolute all coordinates. So these will render the object as it is here, especially as you see it in Unreal. If it's at 000 in Unreal, this is exactly what you'll get in your data set in your trainers. Yeah, that's just an option for centering. So if you ever move the rig, I mean the position of the rig, I'd keep this option off. This is an option to auto launch Lichfield. It's not really needed. This is a quality of life. I built it for people who use Lichfield, or for me because that's what I'm using. So this one just allows you to launch Lichfield when you press the organism training button. So automatically launches it, but then you must have the Lichfield executable path here. For instance, if I come here, copy as path, this guy, I can attach it here. So these automatically, and then there's strategy methods, a couple of methods, just look them up online to see what Lichfield offers. We have Mr. Nav, MCMC, and all those methods. So this allows you to launch Lichfield with like arguments and stuff. So it loads with the correct methods and stuff. So this is a quality of life if you wanna auto launch Lichfield, but it's not really needed. Now there's an option here called a downscale for training. If you turn this on, so this option is for people with like GPUs and stuff. If you want to save on VRAM, let's say you did your export at like if you go to your capture render settings in the engine, you did your export at like a 3080, like a 4K or something, and this will really be hard on your GPU. Training at 4K images, you can do your renders at 4K, and then after you're done, downscale for training. So these downscales, the final renders from whatever resolution you rendered to whatever resolution is specified here. So I have it at 1920 by 1080 because I'm using a laptop for now. I always downscale for training, capture at 4K, and then downscale for training. There's also an option here for exporting camera metadata. So if you wanna, you can export the camera metadata like focal lengths and stuff. I haven't found it like really useful, but I mean, it's the, if you ever need to use the extra camera intrinsics for anything. And there's an option to exporting the depth pass. If you wanna build your own custom trainers that take depth pass as an input, there's always an option here. So these outputs are depth pass for you in EXR format. Okay, so one other thing I want to look at in the pipeline and setting is the masking option. So there's an option for masking, and for the mask option, when we press the quick setup button here, it populates this stencil alpha material because this material is needed for cutting out the subject from the background. So if you just want to isolate certain hero objects or certain hero things that you don't want to capture the whole thing and confuse your trainers and stuff, maybe it's just a capybara. I have a tagging system or a selection system. You can tag objects that you want to have masks for. So I'm gonna turn off the generate mask option. export solid black. This is if you want to flatten the transparent into like a black solid. I'm not sure this is that much needed. But if you have generate masks on, there's a mask target tag. You can either tag your objects or explicitly just drag them here. Maybe the capybara. I'm just gonna maybe the capybara. I can just drag him here. I can use that or just tag objects, which I found more intuitive. So you can change the name of the tag or just have the objects carry this tag. So if it's capybara, I'm just gonna go tag. I'm gonna tag this guy. Tap. Now, when you have the masks generation turned on, the point cloud generation respects the masking feature. So it only generates point clouds where you have the mask targets, or only in objects that have been tagged to include the mask. So for instance, if we have only tagged capybara, if we generate the point cloud here, the visualizers, draw point cloud. Yeah, you see this guy is tagged because it does have a tag. If I look here and I delete the tag and then I do some updates here on the generate flight path, I'm gonna have to, yeah, you see it's gone. The point cloud is only available for the guys with the tag if the masking option is on. That is, if you have the generate masks on, it will only generate point clouds for the tagged objects. So when you export, let's do a quick export for instance, and we have a masking option on. We just quickly do like execute the sequence. Yeah, I'm just gonna stop it there just to show you where was it in images. You see, it's all cut out. You see, I have the XR depth maps because apparently the method was already on. I turn export depth map and turn that guys off and the masks thing off. I'm just gonna delete these guys. So I show you an export without generating masks. It just exports everything. If we have that mask the option turned off, and then we do another capture run. Yeah, you see now we don't have no alpha cutout, just the old scene. So the last thing we want to look at in these categories is a like quality of life feature here called intelligent NBV planning. For the next best view, if we go to Google here, just read through what next best view is a fundamental challenge in robotics, computer vision, and autonomous 3D construction. Involves algorithm calculating the optimal locations and orientation for sensor cameras in order to maximize the information about unknown scenes and objects. So it just uses the same almost like approach. So let's say for instance you have like a scout method. You need a scout method first of all to generate your parts. Let's say this guy, and you can see already generate some parts. If you go and enable the intelligent NBV, the next best view, it looks at what next best view it can find from the first scouting pass it's generated. The camera back off is so much. So this option just pushes the camera nodes along the normal, because it does a complex trace, and when it traces on the objects it gets the normal, and then it pushes the point outwards along the normal. And even the orientation is like the normal, it's like inverting the normal, so it points to the direction of the point, so things might need more nodes, and then this just controls the amount of voxels. So the smaller this number, the more nodes you have. If you make it big, means the voxel size is so big, you only get a few extra NBV points. Yeah, if you can you can turn it into something like a 10. You see, you really have a lot of points now. And then there's so these controls there, it's like a clipping. So any camera that is below these height just gets clipped, you know, like 50. So you don't have points that penetrate the floor and ruin your data sets and stuff. So I mean, you might find use cases for these, especially in chaotic scenes like uh, crazy interior scenes and stuff like that. I mean, it has its use cases. So the weak spot, if a voxel has fewer than these many points, it is flagged as a weak point, needing targeted camera. So you see, you can change this value to, if you have like 10, you see, just self-explanatory, and everything is already here. It's explained if you just over, and everything will be in the documentation. So, but I haven't really used this method a lot, but I mean, it's just there just in case you need to create more robust data set. Okay, so we'll just look at a few case scenarios, a few examples that I've set up here. I have all the maps here, the fisherman town, the fisherman art, custom, interior, plant, and one with a statue. So I'm just gonna start with this one. So this is a fisherman art from Polyhaven. I'm gonna just brought it here, textured, and then just in this simple lighting setup. So the method I'm using here is the cylinder for large subjects. I'm just gonna turn off the camera so you see I only have like 150 frames, and on the setup I only have only like 3 steps. For the lens and render settings, I'm using like a 50mm lens, and I'm exporting at 4K. My motion blur, I'm using my level motion, my level post process, and then I'm downscaling for training here using my standard strategy, and I have generate masks standard, and I'm appending to the existing data. I don't need this because it's only one pass. And then center map, I'm centering these 3 because it's only one capture. I don't need to worry about moving the rigs location, transform and stuff. So you only have one capture, one capture run. You don't necessarily need append to existing unless you're appending extra stuff. So, and then I've set them up to called read, done for training. I'm just gonna run these on. Yeah, come down and start. Yeah, so the export is done. So the next step is just organize and train. If I press this on, you see it optimizes for low VRAM. It does the downscaling, and then when it's done, auto launches Lichtenfeld. It is gonna auto launch Lichtenfeld. We open here. I mean, it brought. I'm just gonna first of all just 1 million splats. So you see this is the camera trajectory or parts and stuff with the standard. You can see as it starts training, you see it's complaining with VRAM and stuff because yeah, I only have like 8 gigs on an RTX harder. But I mean, if you have like really good GPUs, this just becomes very intuitive. I mean, the work machines are like for 4080s and stuff, but I'm only using the laptop for the recording and stuff. So I'll be posting links to the final trained splats on Super Splat, so you get an idea of how the final splats look at with a bit of training and more splats. Yeah, for the next case scenario, we have a gas tank here, gas tank cylinder. This is still a model from Polyhaven 3D models. So the method I'm using here still is the cylinder. So I'm using 2 methods. First of all, the first capture uses a cylinder method that generates 150 frames, just like the other one. We just scrub through. You can see what you'll see in the final view. And then here, for this method, I'm using appending to existing capture, and I have this guy turned off because I want to append another capture on top of this one. Let me run this first of all. And you see, because I need something that captures the top properly here, because if we scrub through this view, you see we never capture the top parts here. So that is what the second run is for. So I'm just going to export this one first. I'll come down and this one is done. Okay, now the first run is done. So I'm going to combine it with I have a slam method walkthrough here. I have some curves, the circular curve. I'm going to move this guy up. So you see, I just want to capture the top part of the gas cylinder. You see now, if I scrub, I only have like 36 frames for that guy. So just append 36 images. Just gonna execute. So these will add up to the previous data set. So I mean the data set grows, and just make sure you have more coverage for the captures. Yeah. Okay, so now the second capture is done. So all the data has been appended, so I'm just organize on train, optimize. You see it's now downscaling on 86 image, 150 for the first run and the 36 for the second run, as a total of 186. And it's done. We can just automatically open next field, and you can see I'm just gonna go again with 1M. I don't need alpha. Yeah, you see the data set. The second one we had, it gets appended to the data. And you see now you have like capture, you get to capture the top part and the main parts of the hero object of the gas tank here. I just gonna let it train and stuff, initialize. They say the first steps are for camera intrinsics and stuff like that. So yeah. Yeah, I'll be providing these trained splats, so you see how they look like. And you can train because they say not be provided. You can just go and train. The only thing that's not provided is the tool, because I'm actually putting that for sale for $10 on Gumroad, so you can find the link in the description too. The project file will be provided. Once you get the tool, just install it and everything will work. Yeah, 1 million splats for these is just, it's crazy. Yeah, you need more. So the next example I have here is a potted plant. Just sits in an empty scene, just an HDRI backdrop here. So, and the method I'm using for this capture is the Fibonacci DOM. If you look at it here, I have just a Fibonacci DOM method because this works well for these kind of hero objects, circular hero objects that are not so elongated and stuff. So if you draw the camera paths, you can see what we're looking at here. Yeah, I might need to give it some sort of like a jitter seed, just right now jitter as well. Yeah, and give it some sort of jitter, yeah. And then I'm only outputting 500 frames for these. I'm just gonna execute and see. I'll be back when it's done. Yeah, so so the method is done. We're ready to go organize and trade and see how that looks. I'm just gonna downscale all 500 images. It does in batches, so it's relatively fast. Yeah, and just maybe make it 2. Now you see the cluster, the camera cluster. I'm just gonna turn those guys off. So you see these guys was centered to read, because you see its position here, and then it's just, if you look at what we did here, number 2, and exporting pipelines, we are the center comma to read. That's why it's centered here on each file, as you can see. Yeah, I'm gonna have this guy train, provide a link to Splat, so you can have a look at how it looks when it's trained. It's gonna take some time to initialize and stuff, but you can see already the colors and stuff already starting now form and stuff. Yeah, clear. Just to have an idea of just to show you that Splat there. So this is the guy trained at like 20. So this is just 20% training with the same 500 images in the same dataset. You can see. Yeah. So the last thing we'll be looking at here is like the interior scene. I have these interior scene provided here. I got this from a cousin of mine who is an architect. So he gave me this scene, so you guys can use it for free. I mean, it will be provided. You can use it for just to test and stuff, just to see how to use these things. Maybe you can relate it much better. I mean, it's just a showcase to show the tool works. I mean, even in interior scenarios, and how you can use them if you have such a scenario. So you can see I have like a path drawn that all around I mean, like the hours and stuff, and I have this extra curve. If you look at the rig here, you see the main one is the one that will come attached to the tool, and then I have an extra spline here because I wanted to capture like because you see if the lenses, the cameras are all the way here, and I want to have more details, especially on like the TV here, on the TV stand, and it stands here. I mean, so that's why I have like these extra spline that just points and captures this region. So if I just turn on the debug, show camera debug visualizes here, if we visualize the parts, you see what each one of these guys is looking at. I mean, it's using the SLAM method, and the side we look at, the sideway tracking, if you go to the SLAM automation methods, it's using the sideway scanning. So that's why these guys are pointed. You see, we do the inversion, so they're pointed like inwards. And then I have multi-tier strategy. I have like five of them. I guess you can go with like 3, but I mean, just showing you can have as many as you want. As you can see here, we don't have any pitch offsets and stuff, so it's looking straight on. If you scrub through, just come here, snap, and do your scrubbing. Just try and see how the camera flies in the scene. And in this method, I'm also using the exclusion regions here. If you go to SLAM exclusion zones, yeah, because in this region, you see the multi-tier, when we generated these curves, some of them were penetrating the couch and you're getting some of the images. Maybe at this point, you have a camera looking, this just ruins the data set and stuff. So, I mean, we have this guy that just culls the points, deletes them from the point, and another one on this side. So there's an extra, I'm using 2 exclusion zones. So this one just cuts the lenses there, the camera nodes that intersect in some weird angles here. Like you see, one is just like facing like really close, so it doesn't really capture any significant info to help in the data set. So that is why. And then you see this extra part that's just looking straight at this guy. You can see we have some sort of jitter in the curves. That's because we have some jitter amount on the methods on those curves here. If you look at the where is it? Yeah, you have a jitter amount of 2. If you turn that guy to 0, we don't have any jitter. So I'm just keeping it at 2, just to have the jitter. Yeah, that generates about 870 frames for the room. And I think I do have the mask on applied to these guys as well. Yeah, you see now the mask target name is wrong. So if you go to these objects and tag them, but for things like these, you don't really need the tags. You don't really need the masking. Those are for very specific case scenarios. But for these one, I have them. You see, everything is tagged as wrong. So if I visualize the point cloud, let's just come here. I'm just gonna turn that guy. Visualize draw the point cloud. You see how the point cloud looks. You can turn off these guys, so you just see the point cloud. It's not so dense. I mean, you can get an idea of places that you need to fill where it doesn't have any. You see like this region. This could have used some extra cameras, like maybe the manual cameras here. So let's try and attach that and see if we have an extra. Just create one that is new, and then I'm just, let's look. Where is this guy looking? I'm just gonna pilot it. Maybe I want it to look like that region that wasn't captured, something like that. I'm piloting. Go back to my tool. Come with the manual cameras. I'm just gonna add that guy. So it gets added to the node. We can visualize. Go to draw camera parts. You see these guys already there. So, and then you can look at the point cloud now. You see it already had. You see the points that were added because it contributed to the raise that from the point cloud. Yeah. So, I mean, for the interior, and then we can just do capture and stuff. Just run and see how that looks. Okay, so the interior is done training. I mean, it's okay. So the interior is done. It's just generating point cloud and then we launch and train. So because I did export it in 4K, I need to downscale it for training to 1080. I'm just gonna organize and train. If I have that method on, when you press this button, just done the downscaling. But if it's off, it skips this entirely and goes on to the next step, which is prepping a data set, or if you have glitched field attached, just auto launches it for you. But you don't need to auto launch. You can just drop the combo folder in your trainers and stuff. Now that you have it down, just organize. Now you can see it's already loaded in list field. I'm just gonna pause the trainer. Just gonna choose a strategy to like Mr. Now have 2 million splats. For a room, you really need a lot of splats, like 5 million plus, but I don't have the budget for that now. So I'm just gonna show you quickly. We'll just tease how it goes. Just it's gonna turn off the cameras and stuff. So you just see the initialization of it as it starts the training. So you can click and see what's happening here. If you have good lighting, in your data set and stuff, if you have like a really good scene, and then you capture like as slightly high resolution, you should get good results. And then you have like a good budget for the number of splats and stuff. Yeah, you should expect good results. But once it trains, the results are not so bad. You can already see just from as it progresses what's happening here. We don't have like massive floaters. You can already see the way the scene looks. Yeah, it's just gonna take some time, but yeah. I have a final scene here, which is the same scene, but with a different like curve. Now this one uses the slump planner that we said we'd come back to. So if you look at the Gaussian trigger, if you go all the way back here, there's an option to launch the slump planner. I'm just gonna turn that guy off. I will even get rid of this guy here, get rid of this guy, none. So if you launch slump planner, you see it launches the planner, attaches the editor utility widget, attaches the blueprint that contains the 2D capture component, and then it gets spawned and it's here now. If we come to the outliner, we look for the BP map scanner. Where is that guy? It's here. You see, just looking at the room, and then it attaches these editor utility widget. If I refresh the scene, you see it captures the scene in an orthographic view. This allows you to like draw curves using this planner. You just define your curves through drawing them. I have these guys already drawn. It's using the 360 cluster. So at each cluster points, it takes images in like a 360, does a 360 rotation, takes images at each step of the rotation, and does that with the multi-tier. I have a few these cameras attached here. These are the manual cameras combined and stuff. And then the exclusion zone, so you see it cuts out the dining part and these other guy. I'm just gonna remove the parts. You can, this removes all the planner or the planner parts. And then when you're using the planning, the visual planner, you come here and say use visual planner. So it disables the other splines, but just uses the ones you draw here. So if I remove all parts, they should be removed. It just needs to be refreshed and stuff. I can just remove that guy just a bit. Yeah, you see it reset all the splines now. And then you can come and now draw like a new spline. So if I have a draw spline selected, and then I just draw, just gonna show you anything, something like that. You go back to, you see you already have your path that matches what's here, and this planner, even if you, it respects the scaling. So the path is always there. Now you can see what's happening. You already have that path drawn. Generate your flight path, and then do the visualize the paths, and you see it's a visual planner. It's just an intuitive. Yeah, in the second version of the plugin, I'll develop more options into these, make it more robust and stuff. But it's just there if you really wanna use like a 2D planner to have a good idea of where you want your cameras to be located or to go. Yeah, just a quality of life feature. And that's just about it. For all the methods, you can go through the documentation, explains everything. It's documented it, so it's easier for you just to get started. Just start playing around with it, convert your scenes and stuff. So the tool will be available for purchase. It's $10 on Gumroad. But the scene and everything is, and all these assets, I'll attach them for free in the project files. So when you get the scenes, when you get the plugin, you can use them. So the plugin right now I've developed for 5.7, Unreal Engine 5.7. I have plans of releasing versions for other engines if anyone needs that. But this works with 5.7. I found it stable enough for the development. I hope this tool helps you, and yeah, makes the Gaussian capture, the dataset capture workflow much more intuitive and easier for you. Just convert your scenes for all kind of case scenarios. Okay, thank you.